I say it is Friday, November 15th. Hello, everybody. Good morning. Good morning. Well, good morning to the morning report. We'll get this ball rolling. I want to take my baby out to another city to get fingerprinted and all that stuff so she can teach the little ones, right? Yeah. Anyway, solar wind right now is 400 kilometers per second. Proton density is about 1. We've had an M1 flare. Well, we've had 2 of them. Yeah, can you dig it?
Can you dig it?
That was pretty funny. Oh, my land. Let's see here. 3889 is still beta gamma delta magnetic field. But let's go ahead and look at the... Let's go ahead and look at the doohickey. The doohickey, I said. Look at the doohickey. Let's see. Oh, well, it ain't on there. Where is it? Oh, and there it is. There you go. All right, so let's look at the X-rays. Yeah, man, a couple of M1s. Oh, looky here. We had an M1 at, looks like 145 hours, and the last M1, we just had it at 2 hours ago, a little less than 2 hours, at 12:20. Look at 2 M1s, bang, bang. Now, there looks like just a little hair of an uptick. Yeah, little hair of an uptick. Why would that be? Well, it's, 3889? 3889 now is approaching the limb, probably about 4 days. It'll get to the limb. And you know what happens when the limb happens, or when it gets to the limb and it's still active? Oh, yeah. But the rest of the disc is quiet. Can you dig it? Can you see that? Yeah. Well, let me turn that down. I just blasted your ears off. Yeah. Oh, anyway. Oh, man. My boy, I think everybody's still asleep. This time change is really throwing people. Yeah. Anyway. As I have a little last drip of the coffee, man, I drank 10 cup. No, it's a 10-ounce cup. But anyway, let's get back to it. So, yeah, we had a couple of M1s. So tonight's full moon is a stupid moon. I think they're all stupid. Hey, tonight's full moon is a super moon for the 4th month in a row. We've decided it's called a stupid moon. Should be anything special, not repetitive. The term supermoon was coined by an astrologer in 1979 to describe the rare moon, usually close to perigee, closest approach to Earth, as much as 14% wider and 30% brighter than the ordinary full moons. Now, mainstream news outlets report 3 to 4 supermoons every year. That's just, insert your own adjective, a moon photo. Ding, 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 ding. Oh, well. What did you see? You want to name a moon? Yeah, you can name the moon right here. I'll put it in chat there. Of course, this is over on Twitch. It's spaceweathergallery2.com/submissions/index.php. And you can name a moon too. Okay. Yeah, oh my God. Let's call it the Clemmer moon? Nah. Keep your pants on there, son. Keep it on. A rare sine wave in the magnetosphere happened. Oh, imagine your hard rock concert. Waves of heavy metal crash against your eardrums. You can barely hear a thing when suddenly the delicate trill of a flute cuts through the cacophony. Something like that happened to Stuart Green in Lancashire, UK, during the severe geomagnetic storm on October 10th of 24. My backyard magnetogram was a riot, says the Green, but when I took a closer look, there was a delicate wave riding on the top of the noise, he says. Green detected a rare pulsation continuous, or PC wave for short. This is research jargon meaning essentially a pure sine wave. In the magnetosphere, PC, waves are classified into 5 types. Hey, man, let's find out what those are. Yeah, 5 types, right? You're going to learn something here today. Let me see. What are the 5 types? Source of lower frequency, ultra light waves, or Anyway, PC 1, 2, 3, 4, and 5. Well, irregular pulsations are PI 1 and PI 2. So geomatic pulsations, ultra low frequency, or ULF waves, cover roughly the frequency range of 1 megahertz to 1 hertz, i.e. from the lowest magnetospheric cavity can support up to the various gyro frequencies. That might be gyro, whatever. Pulsation frequency is considered to be ultra low when it's lower than the natural frequencies of plasma. Like plasma, frequency and ion gyro frequency geomagnetic pulsations were first observed in the ground-based measurements of 1859, the Great Aurora Event, Stewart, 1861. So, hey, the Great Aurora events. Hey, there was a Great Aurora events. A great magnetic storm are often related with auroras of high visual brightness that are usually exceptionally low latitudes. Especially 2 of the high altitude red auroras are seen. Well, if you can see a red aurora, you know what something's happening, right? Low latitude aurora. Well, they have them dated here, Nuremberg. It went all the way down to Nuremberg in 1591. Hungary in 1681. In Europe in 1716. London town, 1839 it had one. 1859 North America, Jamaica, Rome. Yeah, North America and Jamaica. Hey, that's pretty darn good. All the way to Rome. In that, what is that? August 28, 1859. That's a big one. What's even bigger is 1859, September 2nd, had a North America, San Salvador, and Athens, Greece. That's all the way down there, man, isn't it? And February 4th, 1872. Why does that day remind you of, or year remind you of anything, huh? 1872. Bombay, Mexico, Athens, right? Well, on September 25th in 1909, it went all the way down to Singapore. And March 22 and 23 of 1920, Oslo and Washington. May 14 and 15 in 1921, Samoa and Jamaica both saw the auroras, right? Crazy. January 26, 1926, Scandinavia, that's normal. And January 25th, 26, 1938, Azores, the Azores, and North Africa. Pretty darn close to the equator, right? Wow. Of these, to note, 1859 were very important as they resulted in papers about such novel findings of solar flares and geomagnetic pulsations. In addition, here are some more recent events. In 1956, February, Alaska. In September of 57, Mexico, twice, September 13 and 22nd. And February 10th, 1958, North America, Mexico, and the USSR. Yeah. In 1958, Canada, September. And again, that same year, like 5 days in a row, from the 3rd to the 5th. So that's 3 days, right? Yeah. I don't know where the hell rocket absorbs there. 1972, somewhere down there, I don't know where the hell, ISIS 2 and SAR Arc. I guess the rockets were seeing them. 1971, 70, 69, 59. Morning Dayside in 1977. Thermal and Boulder. 1981. Arizona in 1981, April 13. A major storm happened July 13 in 1982. The Great Aurora, March 13, 1989. Another Great Aurora, November 8th of 1991. So, big auroras, right? Yeah. Alrighty then. But pulsations are studied in the situ observation in space of both magnetic and electric fields, and with ground-based magnometers. Yeah, magnetometers. All right. Well, not magnometers. And don't worry about it. In order to study the generation magnetisms of waves, several points should be studied, including frequency characteristics, harmonic structures, spatial distribution, including possible propagation of the waves, polarization characteristics, correlation with IMF and solar wind parameters, correlation of geomagnetic activity, example, phase of storms and substorms, correlation of in situ particle data, or in situ. On the ground, an important additional data comes from optical aurora measurements. Yeah, I went optical. I mean, that's probably like, look, I see it. I want to measure it. How do you measure that? Source of higher frequency, or ULF waves, continuous PC1 and 2 pulsations are locally generated at equatorial magnetospheres by EMIC instability. What the hell's EMIC? Well, let me tell you. Energetic magnetospheric ions are often unstable electromagnetic ions, cyclotrons, or EMIC instability. There are two important consequences for this instability: generation of EMIC waves below the proton gyro frequency, or gyro frequency, and pitch angle scattering of energetic ions and via wave particle. Are you going to sleep yet? Let me get back to it here, baby. Oh, my land. There's so much to learn about this stuff. But are you a geophysicist? No? All right. Sources of the lower frequency waves. At lower frequencies, continuous pulsations sharing the same frequency range may differ in the polarization, harmonic structure, or occurrence region, and have thus different origins. They can divide according to whether they result from local wave particle instability or from coupling of wave energy propagating through the magnetosphere and producing either solar wind, magnetosheath, or magnetopause, or at the magnetopause boundary layer, all referred to as upstream below. Latter type relate to resonances of field lines and magnetospheric cavity. One can categorize these waves, as compressional, related to wave particle interaction with foreshock, toroidal, as day side, both these are day sides. These are both upstream as well. Field line resonance harmonic PC3, PC4 range, compressional PC3 as driver, coupling with fundamental toroidal mode, polaridal PC4, afternoon and evening, local, related to injection of energetic plasma and subsequent low activity convection electric field, occurring in the second harmonic field line resonance frequency. And compressional PC5, night side or dawn, which is also local, like polaidal 4, related to high beta plasma. See, there are different kind of plasmas that come out of the sun. That's what they're saying. And they've categorized them because they all act different. Yeah. And they happen at different times here. Toroidal PC5, dawn and dusk flanks, upstream. Fundamental mode, field line, resonance source in the flanks. And incoherent noise everywhere. Unknown. Increased with magnetic activity. So if this is all incoherent to you, I guess it's incoherent noise. That's what he said. And here's your sign. Be incoherent. Yeah. For upstream generated waves, one important task is to establish linkage between waves, external and internal, to the magnetosphere. The question is, what are the sites of transfer of external to internal wave energy. What are the sites? One model would have compressional oscillations in the foreshock, propagate directly through the shock sheath, the subsolar magnetopause into the lower magnetopause. Hey, did you know there was a sub and a regular one? While the other wave has waves entering along the cusp, cleft, boundary, layer field lines, L shells, right? Transferring the interior dayside magnetosphere via the ionospheric process. Note that all pulsations ultimately derive their energy from the solar wind. This is because the particles taking part in the local instabilities are energized via the convection of the electronic field imposed by solar wind. Similarly, the participating particles and impinging electric field in the ionosphere are solar wind powered. You get that? The precipitating particles and impinging electronic field in the ionosphere are solar wind powered. Not many of us have understood that the solar wind does a lot more than just blow on our planet, you know? It does a lot more. Usually PC waves are recorded only during periods of extreme quiet. They are delicate and hard to detect. Capturing one during riotous geomagnetic activity is extremely unusual. That's because they can't differentiate them things, right? It is a testament to the sensitivity of Green's research grade, albeit homemade, magnometer. It's magnetometer. Not magnometer. Whatever. It's a machine. Or it's a sensitive thing. It's woke. It woke up and got something. And the degree of which every mode of the magnetosphere was simultaneously activated on October 10th storm. You remember the October 10th storm? Yeah, it was incredible. So what? These particles waves matter because they can help satellites survive severe space storms. Fast PC1 and 2 waves scatter or killer electrons out of the Van Allen belt radiation belts, making the region safer for satellites that orbit through the belts when they are supercharged by solar activity. See, PC1 and PC2 waves scatter killer electrons, right? Killer electrons. You ever heard about killer electrons? Well, let me go read that too. Okay, accept it. All right. Yeah, you can read that by yourself if you want to. Even if it's interesting, I think relativistic electrons in the outer Van Allen belt wreak havoc with satellites in geosynchronous orbit. But how do they reach such high energies has been unclear. New data identifies gyro-resonant wave particles interactions as the culprit. These are the killer waves, baby. Yeah, there's a couple of articles there if you want to read those. But we'll talk. Let me see here. Van Allen belt, right? I think it's on this one. Yeah. Van Allen belt is what we look there when the L shells break and it comes and it's back here. This is like the Van Allen belt right behind the Earth. The wind's blowing. It's on the back side, eh? Yeah. It stays there. The world spins, right? But it stays there. But we can see when it bangs on the back of the planet, when a Van Allen belt releases energy, in a reverse solar wind or solar storm. Some people said, nah, that don't happen. Well, I may have explained it wrong, but you got the idea. When all this energy comes back and the Van Allen belt releases energy back to the planet, it can knock the satellites which are flying around, right? Flying around here. You want to see where the satellites are? Let's look at the solar wind. I'll show you. See all these things? These are the satellites. The asynchronous, right? The synchronous satellites, they stay there in the same position. As the Earth spins, they spin with the Earth, right? So when this magnetopause, right, gets buffeted and pulled back, and it breaks the L shells, right, the layers in our atmosphere. That's way out there, by the way. It's like, I don't know, 175 miles or something like that. Pretty far out there, 200 miles. But right here anyway, because the satellites are like 100 miles, maybe 120. Some of the low level ones, they're only going about 75 miles, I think. I think that's what I read. I could be wrong, but you can correct me. I'll allow that to happen. Anyway, this thing bends, and the Van Allen belt's way back there. We can look up Van Allen belt too, just to as you look here. Van Allen belt. The Van Allen belts are two donut-shaped rings, radiation that surround the Earth and trap energetic particles. Did you know that? Yeah, they're on both sides. I only talked about the back one here. Yeah. They are captured and held around the planet's magnetosphere. That held around the planet by that planet's magnetosphere. Earth has two such belts. Sometimes others may be temporarily correlated. The belts are named after James Van Allen, published in articles in 1958. Earth's two main belts, from altitude of 640 to 500 kilometers, or 400 to 36,000 miles above the surface, in which region of radiation levels vary. The belts are inner region, or Earth's magnetic field. The belts are in the inner region of Earth's magnetic field. They trap energetic electrons and protons. Other nuclei, such as alpha particles, are less prevalent. Most of the particles that form the belts are thought to have come from the solar wind, while others arriving as cosmic rays. Yeah, as we go into solar minimum, right? We haven't peaked out at solar max yet. It's supposed to be in 25. There's arguments that we're doing it now, and then it's going to, decrease. Cosmic rays will start to come in. Yeah. Most of the particles that form the belts are thought to have come from the solar wind, while others arrive from cosmic rays. By trapping a solar wind, the magnetic field deflects those energetic particles and protects the atmosphere from destruction. You see, our planet has its own protection, and what we're seeing is, the magnetopause right there. Yeah. The belts endanger satellites, which must have their sensitive components protected with adequate shielding. If they spend significant time near the zone, Apollo astronauts going through the Van Allen belt received very low and harmless dose of radiation. Yeah, just like the Apollos did, right? You don't want to spend any significant time in that area. In 2003, the Van Allen probes detected a transient third radiation belt, which persisted for 4 weeks. Okay? Hey, 2013, I wonder what was going on then. Yeah, solar max. Yeah. Many people have investigated the possibility of trapped charged particles, all going all the way back to 1895, forming the theory basis that the formation of radiation belts themselves. The second Soviet satellite, Sputnik 2, which had detectors designed, followed by U.S. satellites Explorer 1 and Explorer 3, confirmed the existence of the belt in early 1958. Later, they were named the Van Allen belt, right? From the University of Iowa. The trapped radiation was first mapped by Explorer 4, Pioneer 3, and Luna 1. The term Van Allen belts refer to specifically the radiation belts surrounding the Earth. However, similar radiation belts have been discovered around other planets. The Sun does not support long-term radiation belts, as it lacks a stable global dipole field. The Earth's atmosphere limits the belt's particles to regions above 200 to 1,000 kilometers, or 124 to 620 miles, which, while the belts do not extend past 8 Earth radii, right? The belts are confined to a volume which extends about 65 degrees on either sides of the celestial equator. Research in the Van Allen probes are mission aiming to understand the points of predictability, how populations of relativistic electrons and ions in space form or change in response to changes in solar activity and solar wind. NASA Institute of Advanced Concepts, right, funded studies have proposed magnetic scoops to collect antimatter that naturally occurs in the Van Allen belts of Earth, although only about 10 micrograms of antiprotons are estimated to exist in the entire belt. So how are they going to get them when there's only 10 micrograms? Wow. Van Allen probe's mission successfully launched on April 30 in 2012. The primary mission was scheduled to last 2 years, expected to last 4. The probes were deactivated in 2019 after running out of fuel and are expected to deorbit during the 2030s. They put a bomb up in space. And NASA's Goddard Space Flight Center manages the Living with the Star program, of which the Van Allen probes were a project, along with the Solar Dynamics Observatory, SDO. We look at that all the time. The Applied Physics Laboratory was responsible for implementation of the instrument management for the Van Allen probes. So who gets sued? Is it the Applied Physics Lab, Solar Dynamic, or Living Star program, or the Goddard Space Center, or maybe all the above when the damn things come down? I don't know. Radiation belts exist around our planets and moons in the solar system and have magnetic fields powerful enough to sustain them. To date, most of these radiation belts have been poorly mapped. The Voyager program, Voyager 2, only nominally confirmed the existence of similar belts around Uranus and Neptune. Geomagnetic storms can... See, you got a ring around your anus. And Neptune, too. You're around your Neptune. Oh, my gosh. Geomagnetic storms can cause electron density to increase and decrease relatively quickly, approximately about a day or so. Longer timescale process determine overall configuration of the belts. After electron injection increases electron density is often observed to decay exponentially. Those decay time constants are called lifetimes. Measurements from the Van Allen probe B's magnetic electron ion spectrometer, or MAG-EIS, show long electron lifetimes, longer than 100 days. In the inner belt, short electron lifetimes are around 1 to 2 days, are observed in the slot between the belts. And the energy-dependent electron lifetimes are roughly 5 to 20 days, are found in our outer belt. The reason I'm talking about this, because understanding how the sun plays in our planet, what it does to our magnetosphere, what it does to the Van Allen belts around us that protect us from the solar wind and irradiation, understanding all these things, I think, is part of the charging and decharging of our planet. And in relation, we just spoke about all those things, that sometimes they only last 5 to 20 days. We generally look at when we see like an X flare or a big M flare hit our planet, which is energetic particles, right, coming to our planet. Then we say, okay, let's be on watch for a week or so, see what happens. And we've seen where it's been 2 weeks after a big solar storm, right, a very powerful filament come to our planet, and we have 3 7.6s that happened shortly thereafter. Okay? So understanding all this technical jargon and trying to grasp it and to go, outer belt, inner belt, ding, 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 do-si-do, right? Whatever. All these things are really important. So go back and listen to this recording, because it is recording. It'll be posted on YouTube, right? I'm reading off the wiki anyway. The inner belt of the Van Allen extends typically an altitude of 0.2 to 2 Earth radii, L values of 1.2 to 3, or 1,000 kilometers or 620 miles to 12,000 kilometers or 7,500 miles above Earth. In certain cases, when the solar activity is stronger, or the geographical areas such as the South Atlantic anomaly, the inner boundary may decline roughly 200 kilometers above the Earth's surface. The inner belt contains high concentrations of electrons in the range of hundreds of Kelvin volts, that is. And why did I know what that was? I don't know. Let me just make sure. In physics, electron volt, also written as electron volt, and that's the same damn word, is the measurement of amount of kinetic energy gained in a single electron accelerating through the electric potential difference of 1 volt in vacuum. When used as a unit of energy, the numeric value of 1 eV, right? So, or 1 eV in joules, symbol J, is equal to the numerical value of the charge of electron in coulombs. Hey, we got coulombs again, right? Symbol C. Under the 2019 revision of psi, the sets of 1 eV equals the exact value of 1.602, 176, 634 times 10 to the negative 19J. Whatever the frack. Historical electron volt was devised as a standard of unit measures through its usefulness in electrostatic particle acceleration sciences. Because the particle of the electric charge of Q gains then energy of E equals Q times V after passing through a voltage of V. Whatever. Oh my God, these people. Right? Anyway. So, all that to say is the inner belt contains high concentration electrons in the range of hundreds of keV. And I called it Kelvin volts. It might have been. The energy protons energy is exceeding 100 megavolts. Right? One's 1,000 volts, one's a megavolts, MeV. Trapped in relatively strong magnetic fields in the region as compared to the outer belt. It is thought that the proton energies of 50 megavolts, MeV, in the lower belts at a lower altitude are the result of beta decay of neutrons created by cosmic ray collisions with nuclei of upper atmosphere. The source of lower energy protons is believed to be proton diffusion due to the changes in the magnetic field during geomagnetic storms. Due to the slight offset of the belts from Earth's geomagnetic center, the inner Van Allen belt makes its closest approach to the surface at the South Atlantic anomaly. On March 2014, that is, a pattern resembling a zebra stripes was observed in the radiation belts by the Radiation Belt Storm Probes Ion Composition Experiment, RB SPICE, on board the Van Allen probes. The initial theory proposed in 2014 was that due to the tilt of the Earth's magnetic field axis, the planet's rotation generated by oscillating weak electric field that permeates through the entire inner radiation belt. What the hell did they just say? The initial proposed 2014 theory was due to the tilt of the Earth's magnetic field axis. The planet's rotation generates an oscillating, weak electronic field that permeates through the entire inner radiation belt. A 2016 study instead concluded that the zebra stripes were the imprint of ionospheric winds on radiation belts. Boy, the outer belt consists of mainly high energy, 0.1 to 10 MeVs or megavolts, electrons trapped by the Earth's magnetosphere. It is more variable than the inner belt, as it's more easily influenced by solar activity. It is most toroidal in shape. God, that's a fracked up shape. Beginning at an altitude of 3 Earth radii and extending to 10 Earth radii. 13,000 to 60,000 kilometers, or 8,100 to 3,700 miles above Earth's surface. Its greatest intensity is usually about 4 to 5 radii. The outer electron radiation belt is mostly produced by inward radial diffusion and local acceleration due to transfer of energy from Whistler mode plasma waves to radiation belt electrons. That's whisper mode. Radiation belt electrons are also constantly removed by collisions with Earth's atmosphere. Losses due to the magnetopause and outward radial diffusion, the gyrodii, of energetic protons would be large enough to bring them in contact with Earth's atmosphere. Within this belt, the electrons have high flux, and at the outer edge, close to Earth's magnetopause, where geomagnetic field lines open into the geomagnetic tail. The flux of energetic electrons can drop in low interplanetary levels of about 100 or 62 miles and decrease a factor of 1,000. So, in 2014, it discovered that the inner edge of the outer belt was characterized by a very shaped transition. Below the high relativistic electrons, greater than 5 megavolts, cannot penetrate. So, what they discovered was the inner edge of the outer belt is characterized by a very sharp transition, below which highly relativistic electrons, or greater than 5 megavolts, cannot penetrate. The reason for the shield-like behavior is not well yet understood. The trapped particle population in the outer belt is varied, containing electrons and various ions. Most of the ions are formed energetic protons, but by a certain percentage of alpha particles and O positive oxygen ions, similar to those of the ionosphere, but much more energetic. This mixture of ions suggests that ring current particles probably originate from more than one source. The ring current is what I'm very, very interested in. Earth's ring current is responsible for shielding the lower latitudes of the Earth from magnetospheric electric fields. Okay, it's what's protecting us, right? It's important. It's important. Important. I've been listening to too many Eastern people. Not Middle Eastern, just Eastern. The ring current system consists of a band at a distance of 3 to 8 Earth's radii, which lies in the equatorial plane and circulates clockwise around the Earth when viewed from the north. The particles of the region produce a magnetic field in opposition to the Earth's magnetic field. And so an earthly observer would observe a decrease in the magnetic field in this area. The negative deflection of Earth's magnetic field due to the ring current is measured by the DST index. Disturbance storm time index is a measure of the constant or context of space weather. It gives information about the strength of the ring current and Earth around the Earth caused by solar protons and electrons. The ring current energy is mainly carried around by ions, most of which are protons. However, one also sees alpha particles in the ring current, a type of ion that is plentiful in the solar wind. In addition, a certain percentage of oxygen positive ions, similar to those in the ionosphere of Earth, through which are more energetic. These oxygen particles are more energetic than up there in the higher levels. Similar to those in the ionosphere of the Earth, though much more energetic. This mixture of ions suggests that the ring current particles probably come from more than one source. So as the currents of the magnetopause go one way, and you think of that toroid. You remember we talked about the toroid before, and I'm going to see if I have a picture of it. Yeah, I do. Right here. And yeah, I'll bring this over. That's a toroid. That's the wind of our toroid. All right? Such a trip. What they're explaining is all these different types of winds. Right? This is our moon out here, by the way. And these winds, as the Earth is spinning, if you looked at a larger picture, the sun, let's say this is the sun, Earth is rotating around one of these, like this, the moon. It's being spun. It's like taking a hand and spinning or putting the basketball on the finger and spinning it. These things are like the hands spinning it around the planet. These energy particles, the wind, when the solar wind hits our planet, and it interacts with our planet. These things are taking the energy from the sun and bringing it to the Earth, and somewhat slowing it down, somewhat using it, somewhat kicking our ass. But all these things are important in understanding why we look at the sun. So I wanted to bring that to your attention, because I think it's important. The inner belt, the outer belt, and let me see, flux values. Here we go. Here's the Earth's radii right here, right? The degrees. These are like the energy levels, right? And we see this all the time. The omnidirectional flux protons. When we're talking about the solar storms hitting our planet, we're talking about the interaction of the sun and these magnetic fields. Different energies. And that's why I think it's important for us to understand these things. So when we're looking at an image like this, these are the interactions of our sun with the solar wind and the particles and the ions and all the stuff. The spinning of our Earth, and they said a while back, our Earth's core stopped spinning. I don't know how that could be. Maybe it changed direction and they just can't measure it. I don't know. But if the core stopped, I have a problem with that. It's like, uh-oh, Raggy. So looking at the different, you can see, now this is a measurement. It's also a computer-generated thing to really show you the influx of no protons and bunch of protons. The darker blue is the protons hitting our magnetopause. And we have, two sides of the Van Allen belts, plural. I always thought there was one, but there's two, one on either side. And it's above our, if I measured right, if I understood right, above our magnetopause. Yeah, maybe I'm wrong. But anyway, you can see the protons buffeting on our planet right here in that density. That's why the density is measured, right? And then we look at the geomagnetic cut planes of pressure upon our planet, upon our, like these might be the Van Allen belts, I don't know. The magnetosphere cut planes, right? Watch this. This is the pressure put upon our planet. And like I was always telling you, it's like you take a magnet, you put it on the desk, and a similar polarities push it around, right? The strength of one magnet and another magnet can really push it. So that's what I'm saying. That's what's going on. That's why I see the magnetic energy that's out there, although it's minute to us, is very significant to why we have life on this planet and we don't just float off into space. Or we just don't get fried by whatever the sun's given us, or freeze by what the sun doesn't give us. Our atmosphere holds both the hot and the cold in. But our planet releases the heat from its core itself as well, because it's a lot of plasma down there. The Van Allen belts are energetic particles, most of which originate from the solar wind, that are captured by and are held around our planets by the magnetosphere. Right? So when the solar wind's pumping or hitting our planet, the Van Allen belts grab that energy. And let me show you. There's a inner radiation belt, outer radiation belt, right? The magnetic axis, the rotational axis, right? I wonder if there's our image again. We already seen all three of these. And they're the Van Allen belts, right? This is Jupiter's, actually. A cutaway drawing of two radiation belts around Earth. The red is dominated by protons, the outer blue is by electrons. And somehow life was created by all this stuff and continues to be created. There you go. Van Allen belt's influence on solar wind. These aurora-like Birkeland currents were created by scientist Kristen Birkeland in his Terrelia, a magnetized anode globe of evacuated chamber. Pretty far out, man. The Earth is crazy, man. It's not just earthquakes. And so we're looking at a lot of different things. This is what we're looking at. X-ray flux, right? That's what we're looking at when we do these. There's the killer electrons, all right? So enough of that stuff, all right? We'll get back to it. So the planetary K index, all that explains everything we've been talking about every morning. Just a little pieces of it. I hope you got a little bit. And if you did, let me know what it meant. Please. There's no significant coronal holes except for this one and this one. These are going to be solar wind coming out of these. It's funny that this produces some solar wind, but these produce a lot more. But because our planet's like right there, it's not going to affect us too much. And I can show you this too. Always these are computer generated things, right? And you can see the spin of the sun produces like that toroidal thing, or there's a boomer coming out. Oh yeah. And it's going to get us about on the 18th. Gonna scrape by us. Right? Here's the solar wind on the bottom. We went through a lot of solar wind and now we're like hardly any, and then here comes that little bugger. Yeah. Yeah. And then we'll have some more energetic solar wind here shortly, probably around the 1920. Somewhere out there. All right, so let's look at the LASCO. This is the stuff that comes from the sun, and we talked all about that. This is what's blasting off from the sun. That's why we look at this thing. We look at how it affects the Van Allen belts, how it affects our magnetopause, how it affects the surface of the Earth. Well, there's a Popperini, and there's another one. Just a little bit coming at us, and one just went. So right at the very end, there's a little bit of one. Probably from the M1. Somewhere around, 1200. Yeah. Something's over here coming around the corner. Kicking off a lot of energy. Because I don't know what the hell it is other than it's light energy, right? Anyway, let's look at the ground magnetics. All that other stuff affects the ground. Why is that important? That's where you live. That's where you live, right? There's the ground magnetics. We'll learn a little bit more about these things, and the magnetic perturbs over the globe. So our magnetics get buffeted. I'm wondering, I had another headache today. I'm wondering if I'm becoming more sensitive to the flares from the sun. But I'm not sure. Maybe I have too much iron in my blood? Could be. A lot of steak, man. Yeah. I'm very interested to see what's been going on in Chile or the Sandwich Islands, maybe the East Pacific Rise. Some really kind of down in here. My interest anyway. Just see what's going on. All right, so looking at the tremors yesterday, did we have any? 325 of them. All where? Again. Why are we getting these tremors here? Some would say, oh, it's weather. And others would say it's this or that. This is in the ground, baby. These are not earthquakes. These are energy. Vibrations. That's all. And they're picking it up, some sort of anomaly down under the surface that correlate to the surface. And they say, okay, we found this, and this is what's happening. Should look it up what the hell these things mean, right? About whatever. They got earthquakes on here? Earthquakes? Okay, they do. Exotic events? Oh. Mystery explosions on Orcas Island. All right. Yeah. Interesting stuff. All right. What are these things? I'd like to tell you what they are. Add geographic filter. All right, whatever. Before, after. Tremor detection is an evolving science without any established standards. Without any established standards. As time goes on, new techniques incrementally improve our ability to monitor the phenomenon. The underlying algorithm detected tremor at the PNSN was last updated February of 18. For major changes that took place, then see this other system. But like any completely automated process, it was not foolproof, and sometimes erroneous results can sneak in, usually through bad input data. Duh! Problems began surfacing in June of the last year with many bogus tremor detections in the southern Washington that were a result of few misbehaving stations in that region and gave detection algorithm fits. This prompted us to go back to the drawing board and figure out how to automatically exclude this kind of noise so false detection don't make it to the catalog as much. As a result, a few key changes were made to the underlying algorithm to improve accuracy and reliability. The search grid was changed to actually match the curvature of the subduction zone seen below. Okay. Some filtering and pre-processing parameters were changed to reduce false positives. More standards from California were added to see the map above to extend the footprint and capture some tremor that was previously missed. The past 4 years of data, going back to 2017, were reprocessed with the changes. These results, reduction of false events in southern Washington, seen in blue below. See that difference? Ding, 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 ding. And the tremor that was previously missed. The past 4 years of data starting in 2017 were reprocessed with these changes. The result, reduction of false events in the southern Washington, seen in blue ovals, and an increase of tremor detections in northern Cal in the green ovals. The changes also result in lot less scatter, at least particularly because very weak tremor with poorly defined timing and thus larger errors in the location excluding. So ultimately, these changes result in improved tremor catalog product, but it also means that the data plotted on the website will change. Old catalog will be replaced by the new one in 21. The changes only apply going back to 2017. Okay. This tremor detection is an evolving science without established standards. They just ruled out a shitload of stuff that they didn't understand. It's basically what they said. They said, oh, it was like overwhelming us because of false positives. How do they know it was false positives? There's no standard. So they're excluding a bunch of stuff. And I think that algorithm is indicative of anything that happens from the USGS as well, whereas we get false quakes or quakes that happen and they didn't report them. I believe it's all computer generated. I don't believe the guys that are geologists would do it on purpose. So the attitude, oh, they're doing this on purpose, I struggle with that. Now, there is an argument when you talk about, hey, this magnitude was a 5 and they downgraded it to a 4.9 or 4.7, which they've been doing a lot of 4.7s. So, because we bitched about the 4.9 so much, oh no, we're just going to lower it even further. And I think it's because of the algorithms they have. Look, programmer, right? Programming this stuff. Stupid in, stupid out. Errors in, errors out. Because not everybody has a triple-decker brain, and a lot of these guys have, quadruple-decker brains, but they think they're so smart, they don't realize that the anomalies themselves, if there's a consistent anomaly that goes on, it appears random to them, that they exclude. But that too could be something. So capturing that information, setting it aside and separating it from this stuff, I think would probably be beneficial to us to understand that, hey, what you're looking at, you can be so focused on it that you miss something else. And that's why here at JSL, we try to get a bunch of different disciplines. And as we go through the years and as we grow as a group, there will be people with incredible information, such as what I was reading to you. Fully understand. I was grasping some of that. And it's very interesting to me on the magnetic side of our planet. It's really incredible. And understanding the different things, the Van Allen belts, the ring current, and the magnetopause, and the differentiation between the three of them and how they interact with each other. It's like, oh, all right. Then the ground magnetics, and the perturbs. Something's up there is moving and it's causing stuff down here to move too. It's like, what? And, some of the solar rays get all the way to the earth, and then life responds accordingly. It distorts our DNA, creating cancers. Cancer is like an overgrowth of a group of cells that then feed on the cells it was supposed to, because they're distorted. Yeah. Then ends up killing us because, it overtook us. Someday we'll beat cancer. And I'll be happy there. I'll dance a jig on TV. Not wearing a diaper. But I'll be dancing a jig. On TV. What did I see on TV? I don't want to be on TV. Anyway, I digress. Buoys. Let's see if there's any drunk Chinamen out there. First look, I don't see any. We do have a hurricane to talk about. Oh, we got one. Uh-oh. Are you ready? Are you ready? All right. Let's check it out. Nope, not a drunk Chinaman. This is a real thing here. Because it's not the same signature. Unless they change their signature. But I'm not seeing it. Column water height. Almost a meter. Maybe a rogue wave. It could have been a roadway. South Cordova. 188 miles north, 188 nautical miles southeast of Cordova, Alaska. It's not a drunk Chinaman, but it's out in the middle. Now, we can look at the COD and see there is a pretty good storm out there. Looks like one right in the middle of the United States, too. Look up the global. We'll go to the west. We'll go to the dirty. Oh, yeah, a whole bunch of stuff up there, right? Look into global, see if we can get something a little more further west. There you go. So this buoy's right up there. The storm is pushing the waves, eh? All right. NASDAQ is dropping. See an error. All right, let's go ahead and push go. Ding! Big cold air, big push through, a storm went through. Could have been a rogue wave. We'll see. We'll look at the earthquakes. And here's another low pressure coming right into that same area. Look at this cold wind. Ooh, it's going to get cold. California's going to get... Hey, 42, buddy. High fives to you. Are you all cold in SoCal? Looks like some cold air is coming through. It's been a little bit warmer the last 2 days, 2 in the mornings, but I see a lot of cold air moving. Maybe it hasn't gotten to you yet. You got a little bit of... we have a percentage chance of rain. 18% for me. But I think it's done. To this morning was 55, I think. Better than the 40s or the 30s that we've been having. Oh, the headaches near beers? Nah. No. It ain't it. Yeah. The rain has completely said nope today. Yeah. Got about an hour, then I'll be jamming out. To get my steak! I got to take my baby to go get her fingerprints so she can become a teacher. Yeah. They got to make sure they do background checks if you're around kids. It's funny. We should do that to our neighbors. Hey, let's take a background check. Are you on Angie's list? Or what is it? Not Angie's list. Megan's list, right? Yeah. Looks like a lot of cold weather, but anyway. Get back to it, son. Okay. The buoy. Maybe a storm, maybe not. We'll check it out in just a minute. Volcano news today. In the news, according to volcanodiscovery.com. Santa Guido, Fuego, Popo, Simiru, Decono, Reventador, Sangay, and Tenerife. Teen Rife. Whatever. Little Toby popping a 14. I told you, Little Toby is off the hook right now. It's pissed off there in the northern Timor area. Sangay volcano, 20,000 feet. That's about 1,200. Fuego. Yep, popped a 15. Normal. Simiru. Yep. Same thing. Now here's another one. Canary Islands. Tiede volcano. Seismic swarm. Are the Canary Islands going to be popping again? What do you think? It says seismic swarms happening. They're all, M1, M2s. Yep. The depth of the magnitude of these earthquakes are between November 13 and 16. And they are, one is at 0 kilometers in depth, and the other ones are between 10 and 15 mainly. So magma is moving. All right. And Decono. Ibu Dacono, bing, ding, 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 ding. Looks like Ibu or Dacono is really pushing off some crap in the wind. 9,000 foot. Kanolan volcano over there in the Philippines, central Philippines, 9,000 feet. Yeah. I don't know how tall it is. 79. So, hey, ads everywhere. Popo volcanic 20,000. Have a 17.8. It's not a lot either. Little Toby 14 again. So Little Toby's been popping all day today and all night. Actually, be nighttime. Well, late day yesterday, early, because it's 1500 UT right now. And it's no sunlight over there at the moment. It's dark. So late yesterday, early today. Reventador is 14. That's not a lot either. Popo, nothing. 20. Kanolan volcano, 11,000 right there. And it isn't a whole lot, to tell you the truth. Santa Guido has dissipated. Little Toby 14. Seymour, not a lot. Same. It's all chill. On this day in history, thanks to Still in SoCal 42, on November 15th, the Kuril Russians in 2006 had an 8.3. Boom! Right out there. One person was injured in Waikiki by a tsunami with a registered height 34 centimeters at Honolulu, Hawaii. One parking lot was flooded at Nawiwili, Hawaii by a tsunami recorded a height of 88 centimeters. 2 docks were destroyed, at least one damaged in Crescent City, California by a tsunami with a recorded height, a wave height of 176 centimeters. Felt at Misawa and Yokosuka, Japan, at Petrovsk and Kamchatsky, Russia, in eastern and southern Hokkaido. Recorded one, Japan, in western Hokkaido, and Aomori, right? Miyagi, prefecture Honshu. They felt this thing all the way down to down here, right? In 8. That's pretty damn far. I bet you they would have felt it in the Rat Islands too. But over in California, got a wave. Hawaii got waves. Yeah. Sirocco Air, New Mexico, 1906. 1906. We talked about 19... Wait. We're going to talk about 1906 this Saturday. Tomorrow. The great San Francisco earthquake. Boys with toys. Eastern Nebraska, 1877, had a 5.1. Yeah, an aftershock from 1812, 1811. Maybe. Or was the Mid-Atlantic Ridge pounding? And did we see something out there, 1872, out in California? Yeah, baby. Yeah. I don't know. Let's look at the earthquakes. I gave you a lot of stuff to think about today, didn't I? I put you to sleep. I know. All right. Let's go ahead and go back 12 hours. A lot of explosions I'm looking at. Wow, a lot of explosions. Oh, what the hell was that? All right. 6 hours ago, Eastern Turkey. Whoa, there's one. PNG had a 6.6 9 hours ago. I didn't know that. All right, so looking at for 4s and above. There's a 5 in South Panama. Uh-oh! Uh-oh! We also had an earthquake in the Delta. Uh-oh, Sonora, Mexico had a 2.2. Uh-oh. Panama. And it's a 5. We should see something. Oh, even in Hawaii popped. Uh-oh. The trifecta. Increases in there. What am I saying? Watch the rabbit hole. Be part of it. Join the rabbit hole. You know, we work so hard to put these things together for you. You know, and some of you come, not a lot of you. I guess it's just too much. You know. The rabbit hole was created to dive deeper into subjects that needed further examination. Hi, I'm Joe, and my guest and I will take you on a journey of discovery and exploration. We will provide insight and theories regarding the subjects we discuss. Come join us live at joeslicklive.locals.com, or you can join us on Facebook or Twitch or YouTube. Thanks, and look forward to seeing you. And remember, don't get none on you. Well, I hope you got that. I can't tell. Make sure you subscribe and click and like and share. The rabbit holes are probably the best thing that happens other than the morning report here from me, Joe Slick. And, yeah. Yeah. And, yeah. Rabbit holes are a lot of fun. There's a lot of information coming at you. Yeah. And we've been on a very big kick from September 1st. If you haven't, I know I'm interrupting the flow of things here, but if you haven't seen it, when we're looking at the near Earth asteroids there, if you haven't seen Rumble, crapola. Make sure this is all off. Yeah. If you haven't seen Rumble, I had to hide my password from you. Because it is recorded for no other reason. Yeah. Yeah. Because I want you to see it. And it's really, we do a lot. Canuck, I, and Luke, we do a lot to create content for you that is a lot of energy, I should say, right? And the last one was, as I fix the date and time here, that's what I'm doing here. The title here. Yeah. So just so you can see that. And if I do a refresh, there you go. Let me show you real quick. Hey, God bless America. Oh. Rabbit commercial again. Sorry. If you look, this is the Rumble videos that I have. All right, 11:13. Right, actually, I have to fix that freaking date there. Look at that noise. Right there. All right. As you see what I'm doing all the time. Save. All right. Here's 11:13. Was the 1906 San Francisco's not the only deadly earthquake that occurred? We went to a lot of painstaking effort to give you a nice 2-hour and 10-minute video on the other earthquakes that were happening in the area that led up to the 1906. This Saturday, we'll talk about the 1906, and afterward, we'll also talk about the different fault systems that are in the area. So, San Francisco is kind of like Los Angeles, is a bunch of crap. But I have several videos, starting with September 1st, the Western Subducted Plates, U.S. plates, that is. The thrust faults, and on the 4th, California earthquake in trouble, Saturday. That was when the Malibu earthquake happened, right? Then we looked at the Palo Verde's fault on the 14th. We looked at San Jacinto on the 18th. We looked at Elsinore on the 21st. We looked at Newport Inglewood on the 25th. We looked at the California inner borderland faults, which you don't know unless you've been there in the rabbit hole, on the 28th. And then October, we did the outer borderland faults on the 2nd. Santa Barbara Channel, part 1, on the 5th. And San Gabriel and San Ynez faults on the 12th. Santa Barbara, again, part 2 on the 16th. We did the rabbit hole Eastern California faults on the 23rd. The Garlock, Death Valley, Panamint Valley, Ridgecrest earthquake sequence on the 26th. The rabbit hole Owens Valley in the rabbit hole, right? And the Western faults on the 30th. Then in November, we talked about the San Andreas fault, the southern portion of it. On the 7th, on the 9th, we talked about Lompoc, San Francisco, the fault systems that led up to San Francisco. Then last week, or this week, actually 2 days ago, we talked about the 1906. San Francisco is not the only deadly earthquake that happened in that region. That's right. It's not the only one. And we talked several of those quakes. So most of them are about 2 hours, 2 hours, 30 minutes long. Give yourself a listen. And I like Rumble a little bit better than I like over here in YouTube. You can see that we got a couple of views mainly from me. In our dashboard, we can see that was the last one, right? And our content here on YouTube, the morning reports are here. Not every one of them. November 12th was the last one I posted. Today's I will post as well. And then the live, click on the live, and you'll see all the rabbit holes dating, I don't know how many we got, 54 rabbit holes. All right. So, some of them, whatever. And the first one I've got dates back to November 12th, 2023. Right? So there's a rabbit hole down there. And a couple more rabbit holes. These are all live, and then big events that happened, and we'll have to get back and renaming some of those, fixing them, making them presentable, but also all the videos that we have here. 81 videos, mostly reports, emergency reports, and rabbit holes, and the like, over there on YouTube. So just look up YouTube, Joe Slick Live over there on YouTube. You'll find us. Some changes will happen very soon with regards to that, also on Rumble. So be aware. All right, so back to the earthquakes. And, right. There's a Bally Sea. All right, little 2.6. PNG, New Ireland region. Yeah. It's in the Bismarck Sea, actually. A 6.6. And tsunami risk. Hey, let's look at the tsunami. What did it say? No tsunami. All right. No tsunami. 6.7. Yeah. Okay. Northern Iran got a 4.2. And Hidalgo, Mexico. All right. Well, that's interesting. Yeah, it's up the path. And as a Nicaragua, little 3, as you seen, just popped online. And whereas we're going through 4.8, Papua New Guinea again, aftershock, 8 hours ago. Central Turkey popped with a 4.9, and PNG had another 4.5. So that big 6.7's got some aftershocks. Yeah. Southern Cal, 2.3. Southern Italy, 4.2. Wow. Zoom in here. Right on the boot. Right off the boot. Soccer. Or football. I wonder why American football's called football, not run ball. Tonga popped with a 5.4. Tonga. Right over here. Tonga's been actually pretty quiet. We have two large quakes here recently, but pretty quiet. SoCal down in the Delta got a 2.0. Southern Texas even popped with a 2. Eastern Turkey, 4.5. No tsunami. 92 people reported that one. Eastern Turkey. So right out here, they thought maybe it's going to be a tsunami out here. Nope. Off the coast of Oregon, 3.4. Whoa, waggy. And a 2.6 right after that. 6.5 hours ago. Guerrero, Mexico, 3. Offshore Michoacan, 3. Veracruz, there's another one on the other side. So Veracruz and another one, Puebla. That's the third one. The chicken leg is shaking like a bacon in a skillet. Yeah. Oaxaca again, 3.4. Southern Texas got a 3. Ooh. Oaxaca again, a 4. Bellany Island. Where the hell is a Bellany Island? Oh, well down there underneath New Zealand. Got a 5. I thought it would be over here, but bang, it popped over here 4 hours ago. Near 5 hours. New Britain again. PNG popping again. 4.5. It's aftershocking. Oaxaca pops in again with a 4. Banda Sea at 4.3. Then the Loyalty Islands came in at a 5. So we've got a banger here and a banger there. And a banger here. So banger there. Banger everywhere. Oh, thank you, Denise. Southern Texas got another 2.9. Explosion. Northwestern Russia. What the frack? How was there an explosion up there? Whoa! Boom. Did the Ukrainians blow something up? Look, man, they're in a fight for their lives. Yeah. Chiapas had a 4.0. So, Yeah, they're fighting for their lives. Sweden exploding as well. Yeah. And I think that's going to be pretty much it. That is pretty much it. So we'll be watching today and seeing what's going on. Hey, calmness. How you doing, sister? Love you. Red Wagon's in the house. Hey, Red. You know what day it is. Come on. It's Friday. Yeah, it's Friday. It's Friday, baby. Steak Friday. That's right. Gotta love it. Gotta love it. Remember here, we're Monday through Friday here in the mornings, 7 to 9. I'm probably going to move Wednesdays to the evening, just because it's a lot of work to do a morning report, then go to work, then come back and do a rabbit hole. And I'm up, unless I'm up early, so it's kind of still up in the air. Generally, I'm up early. Early for me, it might be late for you. If you're Susan over there in Australia, or Denise in the UK, or Canuck in Commieland up there. There's a reason why it starts with a C. I think it's Commieland. I don't think he's a commie though. Although he does work for the government, or did. Do you ever not work for the government? I don't know. Anyway, thanks, Timmy, Susan, Snowplow King, which, he has a show tonight, too. Yeah. It's called The Shit Show with Luke Klimmer. It's on twitch.tv/snowplow_king. And that's every Friday night at 10 Central Standard Time. If you don't know what time that is, figure it out. Thank you, Budgie Bird. Thank you, 42. Red Wagon, Canuck, Simply Sue, Flutter Girl, Denise in the UK, Croatian Dude 96, and Commons 55. And, of course, our little brother, San Diego Dan Snow.
Wakey, wakey, cupcakey. He's so funny.
Yeah. Oh. Hey, San Diego Dan.
I love the kid. He's a good guy. But anyway, happy Steak Friday, everybody. And remember, don't get none on you. Do not get none on you. Yeah, there you go. There you go. Right there. Yeah. Anyway, the shit show with Luke is real talk for real people, and he doesn't pull any punches. So if it's not your cup of tea, just go somewhere else. But he'll try to engage his audience and engage his person he's talking to. He does interviews with people who are, around him that are truckers and farmers and ranchers and blue collar people, out there busting the nut, trying to make a dollar and survive. Hopefully our new president will, make our lives better and easier. We just don't know. We all have a great expectation. There is a report out there, however, that Israel, when they bombed Iran, they hit the nuclear weapons facility and they destroyed it. Israel destroyed a top secret nuclear weapons research facility during its missile attack last month. So Axios is reporting. Yeah. Let me see if I can find multiple. There we go. This is the article. So if you want to read it, there you have it. Yeah. In late October, Israel's attack in Iran destroyed an active top-secret nuclear weapons research facility in Parchin, according to three U.S. officials. One current Israeli official and one former Israeli official. The strike, which targeted site previously reported to be inactive, significantly damaged Iran's effort over the past year to resume nuclear weapons research. So the officials all said. Yeah. It destroyed some sophisticated equipment used to design plastic explosives that surrounded uranium in a nuclear device that are needed to detonate it. Iran is denying this pursuing of nuclear weapons. They need bullshit. You know that. The Iranian mission to the UN declined to comment. It might be the reason why they got quiet all of a sudden. Oh, the damn Israelis know too much. What's going on? Yeah. Or is it the new president coming in? I don't know. Some people say this, some people say that. The latest news has a lot of people upset about RFK Jr. Yeah. He was tapped to head up the HHS. And there's hope for us out there that somebody will put a stop to them telling you that you don't take your kids to school and that you got to isolate and you got to take every freaking jab they say take, you know, especially when they didn't do it. But who knows? Was it a dry run? Oh, this is funny. You've heard of the actor Sylvester Stallone? Yeah. He calls Trump the second George Washington. Big Daddy Trump in a house. Yeah. Yeah. In California, a man is going to be sentenced for killing a gay guy. Guy lost his melon. He got hit on. He said, "What?" Snuffed him. And I'm making light of it. And I think that's violence is absolutely wrong. But so is telling me that what you want to do in your bedroom and presenting it out there in the universe. Stay in your room. Do whatever the hell you want to do. I don't care. I am not going to entertain your fantasies that you want to live your life by. Put your shit out there in the public, you'll get what the public says. But violence is never the answer. Protect yourself. Oh, man. General Motors is laying off 1,000 workers worldwide. Did you notice that, what was it, 10 years ago when they all got bailed out? You can buy a pickup truck from General Motors. It was a little longer than 10. It was 2008, right? A little bit longer than 10. Well, yeah, a little more than that, all right? 2008, 2009. You can buy a pickup truck, a full-size pickup truck for $21,000, $22,000. You cannot buy one of the same pickup trucks for less than $57,000 today. $57,000 with $10,000 down is going to give you a payment of about $750 a month. That's your mortgage. That's your house payment, your rent, if you live out in the boonies. In the inner city, your rent is $2,000 plus for per bedroom. Yeah. What is going on in this world? Iran has said in writing that it's going to try and kill the former President Trump. Oh, yeah. They said they're going to try. Crazy. Credit card debt today has hit $1.17 trillion. $1.7 trillion? $1.17 trillion. What's the difference? Not a lot. It's still too much damn money. I remember back many years ago, my wife and I, when we went through some really hard times, we had to live off our credit card as well. It took us, 15 years to get out of that mess. Yeah, 15 years. Use your credit card, pay it off every month. Don't hold a balance. There's a report that's also out that thousands of ICE agents are going to be reassigned back into the inner cities. Whereas they were taken out, put on behind a desk under this current administration. Now they're going to be thrown back into the fire. La Migra is being retooled and set out again. It's easier for them the other ones just to leave. It's you're here illegally, get a lawyer or get the hell out. I don't know. I think some of the kids that were born here or brought here when they were super young by their parents, I have a little compassion on them. But I think there's a way to stop some of this. In Georgia, Fulton County Jail, the DOJ, Department of Justice, says they're violating rights of people. Violating the constitutional rights of people in their custody. Where do you think January 6 people went? Not just New York. Not just Rikers. They were moved all around the planet so that nobody could find them. Lost in the system. And the last thing I'll leave you with, or last two things. That illegal, I don't know what you would call this dude. Special counsel. The guy has no power, but somehow the courts are allowing him to do what he's done. Jack Smith has put a pause on his case against the president-elect Donald Trump for mishandling classified documents. They'll just do it when he gets out again. So special counsel needs to go to freaking jail himself. If you remember, when they went into Mar-a-Lago, they messed with some documents and they created some documents that weren't there. You don't remember that, but I do. He had to admit that in court. Going to Mar-a-Lago, the guy said, turn off all the security cameras. They didn't do that. So they videotaped this jagoff go through Melania's underwears and whatever they did. Ugh. If I was her, I would have burned the two of them. Yeah, the two jockeys she has. I'd just get rid of them. She's got others, but I don't know what they are. If somebody touched your jockeys, your private stuff, you don't want their fingerprints on it. Their nose hairs, pulling out their nose hairs. Just burn this crap. And I'm sure that's what she did. It's like I don't go into my wife's purse. Probably maybe 5 times the whole time we've been married for 31 years. Only to get what she knows I'm going to get. Whatever's in there, it's not mine. You have to respect boundaries. And why the hell would the former president hide documents in her underwear drawer? What sicko would do that? What? He's got other places. Mar-a-Lago's huge. Why would he put it in her panty drawer? Because the guys are perverts. Whoever did the search are perverts. And they ought to be fired. Because believe me, Trump's not... look, dude, you just let your mind wander why somebody would put something in the wife's panty drawer. Like she wouldn't know it. She's in there every day or every other day or once a week. I don't know. But why would you put documents in her panty drawer? He's a bit smarter than that. And he wouldn't disrespect his wife that way. Interesting. It's just disgusting. Biden's regulation cost $1.8 trillion over his 4-year term. Our debt is $35 trillion. And his regulations cost $1.8 trillion. So if he didn't have those, it'd be less. Just sick. And if you didn't see Rachel Ziegler, she played Snow White in Disney's movie or something. I didn't see the movie. She made some anti-Trump comments, and Disney's hurting because of it now. She'll be fired soon enough. And also, the last thing I'm going to say is Trump has met with Argentina's president. You know the guy who's just like Trump out there in Argentina? Javier Milei, the first foreign leader to meet with the president-elect since the victory in last week's election. The meeting was confirmed by a person who insisted on an anonymity to discuss a meeting that hadn't yet been announced publicly. So he's got some leaks. Yeah. Milei is a self-described anarcho-capitalist capitalist, a frequent recipient of Trump's praise, addressed the American First Policy Institute at Mar-a-Lago. He slammed left-wing ideologies and saluted Elon Musk's owner of X, saying his social media site is helping to save humanity. Humanity. That's you and me. And Trump says in a closing, it says he'll return to his country and make Argentina great again. You see, most people think crazy. And hitting the news right now, it just came across the wires. Migrants are racing to enter the U.S. before Trump takes office. First, the report was, they're dissipating. No, they're racing to get in now. Yeah. But that's all that's been hitting the big news right now. There's other stuff. I ain't going to talk about it. But it's all over the news. If you want to look at that stuff, you can. Yeah, work vans. Oh my God. Crazy. Hey, try to buy a used car today. Oh my God. 15% interest on a vehicle that's $20,000. Might as well buy a new one. Pay the $750 a month. I mean, usually on a $20,000 car, you're going to pay $450 a month. That's with no interest. But where can you get a $20,000 car? Like, park the car. Go to the park. Because the car's in a park. Yeah. Whatever. Have fun, everybody. It's Friday. Enjoy your weekend. Love you. And remember, don't get none on you. And tomorrow, I don't even have it done yet for you. God bless America. Land of the free. I don't know the song. I'm just making one up. Yeah. Let me fix this time change here. Dun, 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 dun. There we go. The 16th at 6 p.m. my time. Figure it out. There you go. 1 day, 9 hours, 40 minutes, 4 minutes. Love you all. We'll see you next time. And have a great weekend, will you? Be here Saturday, 6 Mountain Standard Time. Don't forget to subscribe. If you want to leave a gratuity, I think it's this. Yeah, there it is. ! TIP there for those on Twitch. streamelements.com/JoeSlickLive/tip. Appreciate y'all. Love you.